Okay, welcome. Today we're going to look at proving the Pythagorean theorem using similar triangles. So go ahead and pull our notes out from yesterday, and we're hopefully going to clear up any misconceptions from yesterday or any pieces you didn't quite get the first time through. Remember, during the video you can pause it or re-listen to portions again to make sure your notes are caught up or that you understand what's going on. Okay, our objective today is students will be able to write the proof of the Pythagorean theorem without using notes. That simply means you need to be able to walk up to the board or take a blank piece of paper and do this proof from memory. And able to do that is not memorize it, but understand what's going on, and that's our goal for today. So let's go ahead and begin. First thing you need to do is just draw a right triangle. That's what I've done here. I've labeled my triangle A, B, and C. We are next going to split this triangle by drawing an altitude from A to the side BC, or a hypotenuse, and form two new triangles, two smaller triangles. So let's go ahead and do that right now. There it is. So we're going to call this point D and realize it makes a right angle. Alright, proving using similar triangles means I need to show that these two triangles are similar to the big triangle. In order to do that, I'm going to use one of our methods, and that would be angle, angle. Because right now I can see that the smaller triangle, triangle ABD, has a right angle. So does the large triangle. So they have a congruent angle. Right angles are congruent. They also share side B. That means the large triangle has angle B. Excuse me, I said side B. They share angle B. That means the large triangle has angle B. So does the small triangle. So they have a shared angle, which means shared angles are congruent. It's the same angle. So we can say triangle ABC is congruent to triangle. We got to get the statement right. We got to match up corresponding angles. Angle A is the right angle of the large triangle, so its corresponding angle would be angle D. Let's see, B is next, and that's the shared angle, so I have to write BB. And the last one is A. So there are the corresponding angles. A corresponds with D, B corresponds with itself, and C corresponds with A. And that is proved by angle, angle. Okay, I can do similar proof for the medium-sized triangle. Again, another right angle. And this time they share side C. So the large triangle has side C, and so does the medium-sized triangle. Therefore, by angle, angle, the two right angles, and the shared side, we can say that these two triangles are similar. So triangle again, A, B, C is similar. Now get your statement right. Corresponding angles. Angle A corresponds with angle D. We went to B this time, which is up here, and it's not the shared side, so in this case, corresponding angle would be A, and the shared angle would be C. Again, that's by angle, angle. Okay, now we prove that these two triangles are similar. We can move on to the next step. We don't need to prove that the smaller triangle is similar to the medium-sized triangle, but we could. Okay, so our next step is I'm going to redraw these. I'm going to look for proportions. So I'm going to kind of pull those triangles out and so we can see what's going on, and that's what I've done here. So I have this triangle ABC. Split up the small triangle, which is ABD, which is over here. And notice that I wrote C. One of the common errors is go ahead and change that, is mislabel things. If we mislabel things, then our proof will not work. So make sure you get your labels right. So ABD, this side needs to be A. Let's check our other one. DAC, DAC, D is our right angles, good. This goes to A, then to C. Okay, so it looks like we split them up correctly. Let's start looking for proportions now. We know they're similar, so we know they're proportionate. So we're going to make some ratios out of these. I'm going to start with the large triangle and the medium triangle, and I'm going to say that, it's my medium triangle, sorry, brain freeze. There we go. I'm going to say that side AC, the bottom leg of the triangle, the bottom side, the leg, over its hypotenuse, we always put it over the hypotenuse, which is BC, is equal to or the same as the bottom side of the middle triangle, which is DC, over its leg, which is AC. Now the reason I chose the bottom leg is I was looking ahead and seeing, okay, the bottom leg or the bottom side of the medium triangle also makes up the hypotenuse. And that's what I'm trying to use, the sides that make up the hypotenuse. So let's see if we can do the same thing with the smaller triangle. So the large triangle, again, since we use the bottom leg, let's use the side leg, AB, and again, that's over its hypotenuse, BC, and that's going to be the same as, well, we can see that BD makes up the hypotenuse of the large triangle, and it's also, it's hard to see on this drawing, but it's also the shorter side, just as BA was the shorter side. So they are corresponding. Let's go DB over its hypotenuse, BA. Okay, so that's important. We're using the sides that make up the hypotenuse. So the small one would be BD, the large one would be DC, and that kind of helps us write our proportions. If we don't do that correctly, our proof is not going to work out. Our next step is to cross multiply. So AC times itself is AC times AC, or AC squared, which is equal to BC times DC on the other side. We have AB times BA. Remember, we can reorder the letters as AB, so this is actually AB squared. And that's equal to BC times DB. Okay, so again, all we did is we simply cross multiplied. Okay, let's move on to the next step. So once we've cross multiplied the correct proportions, we're simply going to add these guys together. So I'm going to go ahead and slap a plus sign in here. If I add this equation with this equation, adding the left sides of the equation, I get AC squared plus AB squared. And again, we just added this piece with this piece. Now if we go to the left side of the equation, oops, dragged my pen there, let's get rid of that. Ooh, now I'm really bad, wrong slide. There we go, I'm back, sorry. Technical difficulty. And let's get to the right pen, there we go. Okay, we added the left sides of the equation. Let's go ahead and do the right side of the equation. Add those up, and we should get BC times DC plus BC times DB. Now notice they're not like terms. We can't combine these. So one trick we learned, though, is when we're adding two things together and they're not like terms, we can also factor, and that's what we're going to do next. So while the left side's going to remain the same, I'm going to factor out a common term, or common side in this case, which is BC, which leaves me with BC on the left side and plus DB on the right side. Okay, again, the left side remained the same. Now, if I look at DC plus DB, I'm going to need my triangle up here, which we can't see. I'm going to show you that this is actually side BC. So DC plus DB, let's go back and look at that. BC is actually this side length here, and DB is this side length here. If I add those together, I get the entire side length, which is BC. So BD and DC added together is actually BC. And that's why this goes to BC. Okay, let's finish up our proof now. And having some technical difficulties here. Almost done. Okay, so now we have A squared plus AC squared plus AB squared. So let's go ahead and just bring this down. We're going to go AC squared plus AB squared is equal to BC times BC, which is BC squared. Now, we know that our Pythagorean theorem is A squared plus B squared is equal to C squared, and that's actually what we have here. Okay, we are naming these sides. These are actually names of sides. This is side AC plus side AB is equal to BC. Now, if we go name those sides, and that's what we'll do right now, so let's jump back up and look at our triangle. If I name side AB, let's call him just lowercase a. He represents the side length. Side AB is lowercase a. Side AC is lowercase b, so we'll just name him that. Side BC, we'll name him just simply lowercase c. I can say that BA or A, AC is B, and BC is C, with a quick substitution. A squared plus B squared is equal to C squared. And that is your proof. So go ahead and look it over and make sure you don't have any questions. There are some key components. That one is very key. How did I get to BC? Make sure you understand that. And understand how these proportions come about. How did I know to use DC here and DB over here? Again, it has to do with the hypotenuse. Other than that, it's just making proportions, cross-multiplying, adding them together, and you're pretty much done at that point. So if you have any other questions, please let me know.